Testing, testing. Perfect. All right. Don't mind me. I'm just going to be on here and making sure everything's up and running. All right. Nightbot finally works. Now, will you actually respond a little quicker this time? That's better. Testing out some noise filters. Testing, testing. Have I killed my voice? How about that? Is that better? It's the problem, it keeps automatically resetting that. All right. Testing, testing, normal volume. That's better. Hey, can you talk a little bit for me? Test out my audio filters. All right. Didn't pick up any of that.
Do you hear those? Tacos? 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 Tacos?
Okay, so it barely picks up your voice at all. That's really nice. All right. Well, hello everyone. My audio should be working. No one's currently watching, but if my audio isn't working and you watch it later, I am so sorry. First, I would like to acknowledge my past stream I did just last Saturday was really awful. I had such bad nerves. I had a panic attack right in the middle of it. And so I didn't really do a great job of introducing myself, so I'd like to redo that. I am a software developer. I've been working uh, at my current company for about 4 years. Just before that, I graduated college with a bachelor's degree in computer science. So having graduated right in the middle of, well, the pandemic, there wasn't a whole lot of job opportunities at the time. I was lucky, however. I happened to know someone who was actually looking for a software developer. What's unlucky is I, for the last 4 years, have been the only software developer at the company. So while I have a good bit more knowledge than someone who recently graduated, let's just say I have a couple of holes in my knowledge. And that leads me to why I'm even starting this channel in the first place. I've actually wanted to start one for several years. Never really was able to get myself started. There was, I thought maybe, oh, I'll do a gaming channel. But that just didn't seem like something I really wanted to do. But in general, I'm hoping to learn basically as much from this channel, from making it, as you all do watching it. And along those lines, I chose this CDN project because it's something that I am pretty thoroughly unfamiliar with. I'm aware of what a CDN does, but I've never worked on a project of this type. But I wanted a project that was going to push me. So here we are. And let's see. In this stream, what I'm going to do is I'm going to go into some research into some technologies that I haven't really been exposed to. I haven't really had to use them at my current job. For example, where I work, all of what I do is on, or most of what I do, I should say, is on existing systems. And I haven't really had the opportunity to work much with Docker. So my understanding is that is a big hole in my knowledge that I'm hoping to overcome. I'm hoping that watching me do that will help you learn some too. Let's see. Before we get right into it, I just want to go into a brief explanation of what a CDN actually is. I know I covered that in the last video, but again, last video was hard to watch, I would say. I rewatched it and it was just difficult to get through. So, I'm hoping everyone can see that. So the general idea here is that these servers in the center represent, oh, let's say Netflix. These, what are they? Rust colored. These rust colored servers out at the edge of the cloud are our CDN. The idea here is that one of those servers, those rust colored servers, might be in the northeast of the US, one of them might be in the southwest, and you'd have more than three, obviously. But being physically close to all of these, well, clients is going to make it so that the data can get to them. For example, videos from Netflix can get to them with less latency. And also, it'll make it so all four of these clients, or let's say 4 million won't have to hit the actual Netflix servers all at the same time. Instead, they hit those edge servers to save the oh, what do I want to call that? The main servers, I guess, from having to, well, basically from being DOSed by their own clients. Well, with that out of the way, there are a couple things that we're going to be researching. Just going to open up my notes here. These are some previous notes that I took on the last episode. So, a couple things we're going to go over. We're going to go over geography based DNS, where essentially the DNS server will redirect you to a local machine, well, more local than, for example, the UK would be if you're in Connecticut. We're also going to research all four of these: Terraform, AWS, Azure, and Kubernetes. For those of you who don't know, Terraform is essentially a way to allocate and deallocate physical server resources when you do or don't need them anymore. AWS and Azure, I would hope most people who are watching this stream at least know a little bit about what they are, but essentially they are cloud compute platforms that offer a whole host of services. Let's be honest, if we wanted to, we could just use their CDNs instead, but that's not what this stream is about. If we wanted to do that, I might as well just not stream anything. Then we're going to go over Kubernetes, which I have not, well, I haven't worked with Docker, so I haven't worked with Kubernetes either. And actually, I understand Docker a whole lot more than I understand Kubernetes, so that's going to be one of the things that we probably research a lot. Let's see. For the actual load balancing, we could consider using a third party. Again, AWS and Azure will provide load balancers for a fee. Or we can set up our own load balancer using Nginx or Apache with a couple modules. There's the proxy mod and there's the load balancer mod. Then there are a couple that I haven't really heard of before. Like these are, you can hardly go without hearing about these, but HA proxy, I'm going to assume this is pronounced traffic, even though in my head it can't be. And then there's Metal LB. So we're going to go in and research a little bit more about those. And something that I took notes on last episode is DDoS protection strategies. I am actually going to make that a future requirement because I believe that this project is big enough and we're going to add that on later. So I'm just going to make a note of that. Now, that being said, let's get into it. Change over my screen. All right. You'll notice here I'm using Edge. Don't yell at me. I hate Edge. But the good thing about this is I'm not signed into anything on it. It protects my privacy from you guys, you know? First thing we are going to look at is what language we would want to use for the main software that's going to be part of this CDN. So, a couple ones that I put together that I want to look into are C and C++, Rust, Golang, Python, and Node.js. We're going to look at each of these in turn. Let's start with C and C++. This isn't what I would typically think of as a web language, and I'm pretty sure anyone would agree with me on that. But what we're looking for in this CDN is performance, really, to get right down to it. We want this CDN to be fast. However, C and C++, first of all, not great web language, and it can be really easy to cause memory leaks, security bugs, and honestly, I only included it in this list because it's the first programming language that I ever learned. I've hardly ever had to use it, outside of college anyway. And I'm assuming that most everyone in this stream already knows a little bit about C and C++. So we're going to go on to Rust. It's a little bit more of a modern programming language. And unfortunately, it's one that I haven't had the opportunity to get acquainted with just yet. So we're going to look at that. Let's just look at a tutorial here. I have looked a little bit at it in the last week. And let's see, learn Rust. Well, before I go into this, what I've found out is that it's a modern, almost replacement for C and C++. It's great with easy concurrency, or I shouldn't say easy, because apparently the learning curve is pretty steep. But it's great with concurrency. It is highly performant, just like C and C++ are. There's really strong memory safety features, so it's really hard to cause memory leaks and all that kind of stuff. And because of all that security on pointers, specifically, I won't say you can't cause security flaws in it, but it's a lot harder to. In addition, there's several good libraries apparently for, well, for putting it out on the web. So let's go ahead and see where I should get started. I'm not going to read the book on a live stream. Rustlings guides you through downloading and setting up the Rust toolchain and teaches you the basics of reading and writing Rust syntax on the command line. Okay, sure. All right. Project contains small exercise, get you started reading and writing Rust code. So I'm not looking to get anything installed on my computer until I decide what technology stack we actually want to go for. Um, Rust by example might be a good place to go. This will give us a lot of good examples. All right, let's see. Hello World, always a good place to start. Comments, very C style. Let's see. We have an in-browser compiler. That's nice. What's this? I mean, most of this very C style. Obviously, this is a little different, but I can deal with that. And the exclamation point. What is that about? Well, functions need that. It's a macro. Okay, macros look like functions except that their name ends with a bang. All right, cool. Macros are expanded into source code that gets compiled with the rest of the program. Like macros in C and other languages, Rust macros are expanded into abstract syntax trees rather than string preprocessing, so you don't get unexpected precedence bugs. All right. All right, let's go back to the hello world. That seems pretty straightforward. And this is the compiler, rustc hello.rs. And we just run the output. Yeah, that seems good. You know what? I might as well follow along with this. We're just going to copy and paste. Put in, what is that? I'm a rustacean. Gotta love the humor. I have heard that Rust has a whole lot of humor involved in all their libraries and everything. And apparently people who code in Rust are called rustaceans. Cool. I'm good with that. Next, let's learn about primitives. Um, okay. So fairly similar in some of the rules, it looks like, to C and C++. The unit type. A possible value is an empty tuple. Hmm. I'm going to have to see an example of why that's useful. Unless that's used for null, and they don't have their own null. Hmm. All right. I am going to try to go through this as quickly as possible so we don't take too long researching. Let's look at custom types. Struct, well, okay, you're not giving me a whole lot of information on custom types. Oh, I've been missing this whole thing here on the side. All right. Well, function borrows a slice. That is something that I've looked into a little bit during the last week. Is this whole weird thing of borrowing. The ampersand there, in case you're not familiar with Rust, apparently the ampersand does not really have much to do with addressing and pointers and all that. What it really means is, I hope I don't get this wrong for you guys, but it's borrowing the value of the variable that's passed into the function. It's not a concept that I've heard of in any other programming language, but it's apparently very useful. It sounds very useful in creating memory safety. It just sounds also incredibly frustrating. But if we decide to use Rust for our CDN, we'll find out if that's the case. Look at custom types. Oh, wait a second. I am noticing that there's no such, well, unless it's somewhere else. There's struct and enums, but I'm not seeing classes. Um, is this not an object-oriented language? That's fine if it's not, but I don't see where else it would be. Okay. That works well enough for object-oriented. How do you... Hmm. How do you put a function in one of those? I assume you could assign a lambda. Yeah, I imagine how that's how they would do it, is they'd assign a lambda to a variable inside the struct. Although part of me thinks that wouldn't work super well with their memory safety features, but I'm sure they've got a way to do it. They have to. Right. So in order to avoid, oh, let's just take a look at this methods. I have all point associated functions and methods go in here. So it's an origin function, returns a point. I have to assume that means it returns a point. And okay, for some reason it doesn't have a return keyword. Not like it has to, but normally it's what I'd expect. But that's more or less straightforward. I'm not sure I love how they've done this whole thing. Okay. Looking at it, I'm pretty sure I could deal with Rust. It would be a steep learning curve, but it's close enough to see, at least in the syntax. It's probably very different once you start getting into it, but the syntax is close enough that I could probably deal with the rest. Let's move on to our next language. Let me look at my notes. Golang. So I haven't looked that much into Golang. Let's take a look. So, okay, apparently it has built-in concurrency. That is one thing I have heard, is that Go is extremely strong in the concurrency department with let's click here on learn. I love this. Go by example. We have another hello world. All right. By the way, I should go back just for a second and mention what I'm looking for in all of these languages. The biggest criteria are scalability, performance, and cost. Scalability and performance, obviously, because it's a CDN, which is meant to be receiving a lot of requests. And if each individual server that we spin up isn't particularly performant, well, then we're going to have to spin up more servers, and that costs more. Cost is a major factor because I'm just one person. I don't have a big company behind me, so I'm not going to be paying a whole ton of money for proprietary languages or proprietary software. But back to Golang. FMT. So that means format, print line. Why? T dot print line. Hello world. Why is print line part of this? I need to know more about this package. Package, library, something. Go run hello world.go. All right, so it's okay. All right, so it provides a really easy way to, wow, the word escapes me, compile it or to, oh, I know this word, Python, Java, they are all interpreted languages. Yeah, we can run it through an interpreter or we can compile it. That's really nice. Okay, let's look really quickly at some, just a little bit more of Go. Again, we're not going to go through the entire tutorial on any of these languages. I'm just going to get a feel for some of them. All right, Go plus lang. Good. 1 plus 1 equals. Okay, that's really similar to Python, something we can do. Okay. All right. What are we doing here? Shorthand for declaring and initializing a variable. Oh. Oh, okay. That's okay, so it just automatically detects whatever the type is. Let's see, we have if else. That's pretty standard. That's even similar to C. Yeah, that's fine. For loops. Yeah, okay. Wait, what is this? For, hold on, does this mean, okay. Oh, well, I should have read at the very top. For is goes only looping construct, so there aren't any while loops. But they've built in all the functionality of a while loop into for. I wonder, do they have anything like a do while? I'm not seeing it in this example. Well, if we decide to go, then I'll probably learn that. Oh my goodness. Yeah, we're definitely not going to go through all of that. But all right, this is definitely meant to be scalable and secure and reliable. I mean, this is developed by Google, isn't it? That's not just me being crazy. Yeah, designed at Google. I know it's open source, or at least I'm fairly sure it's open source, but it is developed by a team at Google. All right. Okay. All right. Go looks cool. So far, I'm definitely leaning away from C and C++ towards either Go or Rust. Let's see. Next is Python. Now, I use Python all the time. Super quick to develop with, super easy to read and write. Now, the problem with Python, well, there's multiple, but the main problem is that it can be pretty slow. Like, compared to just about any compiled language, ridiculously slow. Add to that that you have the global interpreter lock, makes it so you can't really use multi-threading properly. And honestly, one of my favorite languages for quick prototyping, or even sometimes for just for writing an actual app in, I think that goes out the window for this CDN. Uh, it is definitely not performant. And let's see, Node.js is the last one I was looking at. Now, I'll be honest, I've learned a little bit about Node.js in college, and ever since then, I really decided that I don't like using JavaScript on the back end. That could just be me being biased, bigoted, stupid, whatever you want to call it. I just don't like JavaScript on the back end. Let's see. We're going to look now at load balancers. By the way, if anyone wants me to look into a different language that just wasn't listed here, I know no one's currently watching this, but leave me a comment down below. You watch it later. I'll check out that language. But right now, we're going to go into load balancers. All right, first one we're going to look at is Nginx. Now, obviously, it's not just a load balancer. It's a fully featured, what's it called, HTTP server. But we're just going to be looking at it for a load balancer right now. And in fact, I think it'll be very nice to compare. So I'm going to actually compare it directly versus Apache. So Nginx versus Apache for load balancing. Um, oh, so it excels at serving static content quickly. That actually sounds really nice. No, I have to stay focused. We're looking specifically at load balancing. Let's go just in terms of performance because I'm not seeing very many articles that are gonna directly compare them specifically on load balancing. Let's look at speed. Right, so they're both the same on a small static file. Nginx clearly one with a large static file. Okay. Okay, PHP, apparently no difference. Okay, Nginx. Nginx beats Apache in terms of speed. Is there anything then that we need Apache for? It does have a high variety of modules. I have worked with Apache, so I'm aware that, my goodness, it has a ton of modules, and you can make your own, of course. But for the most part, there's usually no need to. All right. Well, I'm going to say that since Nginx is very clearly faster and what we're mainly worried about is performance, we're going to go with Nginx. If anyone disagrees with me, go ahead and leave a comment down below. I'd love to hear about that. Um, I should mention, however, we are going to look at a couple other different load balancers too. Let's see. HA proxy. Let's go ahead and do Nginx versus HA proxy. And actually, I am going to take just a minute or two. I'm going to need to take just a short break. I will be back in just a moment. All right, thanks for your patience. If you're watching this after the fact, which honestly is the only way you're watching that last couple minutes, then I have probably filtered out or cut out that several minutes of silence. But let's go back to what we were just doing. There we go. Nginx, Nginx versus HA proxy. Right? Performance. That's exactly what we want. Wow, HA proxy is really good at the concurrency. Max requests per sec. Okay, theoretical. Theoretical doesn't really mean that much in many cases. Caching, which is a big part of CDNs, that's really nice that Nginx has that built in. And rate limiting. Okay, yeah, both of them. All right, so this is good with dynamic content and complex load balancing. But Nginx is really good for managing concurrent connections. Hey, go away. All right, well, let's think about this just a minute. We're using this for our load balancer. So what's really important here? Say it's probably these two that are the most important: concurrent connections and max requests per second. As always, anyone disagrees with me, go ahead, write about it down in the comments. Like I said right at the beginning of this stream, there are a lot of holes in my knowledge because of, well, just the context of where I work. Because of that, I'm gonna say HA proxy might be better for a load balancer for what we're using. Mm. I do like the Nginx as comprehensive rate limiting. So it has some of that DDoS protection built in. It's probably not going to be enough DDoS protection. We would probably still have to have something on top of that. But that is nice. But of course, HA proxy has rate limiting too. The only reason I would choose Nginx out of these two is because it's easier to configure. But that's not the whole point of this project here. Is I want a project that's going to challenge me. I'm not going to choose the harder option just because it's harder. But here it looks like HA proxy is probably the actual better choice. So I'm going to deal with the more difficult configuration. Let me go ahead and just take a couple notes on this. All right, so language. By the way, if anyone is... Hold on. Why are you not seeing my notes? That's odd. Hold on, technical difficulties. All right. That'll do the trick. All right. So for language, what I'm leaning towards is either Golang or Rust. I still haven't quite decided between the two of those. For load balancing, what are you doing? Bulleted list. All right. I'm leaning towards HA proxy, but I still have yet to look at traffic and metal LB. Let's look at traffic. Traefik. Traffic is how my brain wants to pronounce it, but I'm quite sure that's supposed to be pronounced traffic. So back over here. Let's take a look. HA proxy versus, I'm just going to copy and paste it, traffic. So I want to explain, just in case the diagram earlier wasn't totally clear. So this proxy right here, in our case, what it's actually referring to is the load balancer. These origin servers, they're not talking about Netflix. They are talking about our CDN servers in this case. Obviously, this diagram isn't meant to show a CDN. It's meant to show a load balancer case, where in our case in the CDN, the load balancer goes in front of the rest of the CDN, and then the rest of the CDN goes in front of, let's say, Netflix or your web app, whatever it may be. But let's move past that. Let's see. Traffic versus HA proxy. Okay, I do like that it integrates very well apparently with Docker Kubernetes, which I haven't looked at too closely, but most likely I think I am going to end up using both of those. but we'll get back to that in a bit. All right, I mean, these seem like fairly standard options for load balancing. My favorite in this case is probably least connection, although that's the lowest number of active connections. What we would really want is, because if we have one node that's has a low number of connections, but those connections are taking up a ton of CPU, and another one that has more connections, but it's waiting on IO bound tasks, for example, we want one that's we want to pass our requests to the most responsive server, not the one that has the fewest connections. There's a difference. But I wonder if it's easy to actually achieve that. According to this, it's not one of the options for traffic, but that doesn't rule out traffic. All right, let's look at HA proxy. We've already looked a little bit at it, but can't hurt. Hmm. Okay, this is going to be important. Um, so what this means, um, SSL offloading, is that AJ proxy would take care of encrypting and decrypting SSL, meaning it would pass unencrypted traffic straight back to our CDN servers, which would then pass it back to HA proxy to encrypt it back to the client. Now let me look back at this. Does traffic have that? If traffic doesn't have that, that's a major oversight, and we would definitely want to. I'm just going to look somewhere else specifically for that. Okay, alright, so it does. It just doesn't specifically mention it in this comparison. Seems like they should have mentioned it, but whatever. Alright, session persistence. Alright, fine. Health monitors, traffic management, detailed logging. All good. We're not going to look at tutorials on that right now. Let's see what comes after that. Metal LB. So I haven't decided yet between HA proxy and traffic. I'm just going to note that down there. Well, let's look at Metal LB here. Okay, a bare metal load balancer specifically for Kubernetes. All right. Nice that it specifically integrates with Kubernetes. That's very nice. Hmm. Let's just compare this to HA proxy and see what we're working with. That's not really a good comparison article. All right, so I'm not 100% sure, but it seems like Metal LB is not exactly what we're looking for. So it looks like our choices are between HA proxy and traffic. Possibly Nginx, but I'm leaning towards just the two. All right, moving on from excuse me, so sorry. Moving on from load balancing, we have resource allocation. There was really only one that I really looked at and found interesting, and it was Terraform. So just to go over it here, I'm not going to spend too much time on this because there's only one that I'm planning on going for. The idea is that Terraform allows you to automatically spin up and uh, well, allocate and deallocate. Let's put it that way. Any infrastructure like servers or well, you could allocate a load balancer, but we're doing our own. Um, the idea behind that is that you normally might have this is just an example 1,000 requests per minute at one of the CDN locations, and that's pretty low, right? So you might not need as many servers to handle all that. But then if it spikes to, let's say, 20,000 per minute, you're going to need some more servers. Terraform, mixed with some monitoring software, will be able to detect that those servers are overloaded and then automatically spin up some more. Meanwhile, if that traffic then dips again back down to 1,000 for a while, well, then we don't need those extra servers anymore. They're just running, doing nothing, costing money. We want to deallocate them, take them down. That's the idea for Terraform. I'm just gonna put that down here in my notes. Like I said, if anyone wants me to look at something else for resource allocation, some competitor for Terraform, give me a heads up, give me a comment down below. But with that, we're also going to move on into geographic based DNS. I've been looking forward to researching this one because I know that it exists and I have no idea how it works. So for this one, I'm actually going to start off with something that is apparently fairly divisive. That's ChatGPT. Now, there are a couple of rules for ChatGPT. The first rule, probably the most important rule, you never trust anything ChatGPT says as ground truth. You always have to doubt it. That being said, it's great for answering certain questions. So I'm just going to ask it, what are some topics I should know about if I want to understand what geographic based DNS? All right, there's a lot of them. Let's see if I can spell correctly. Let's go with just the topics I would need for actually using it. All right, so DNS basics. Okay, fine. It assumes I don't know anything about DNS. GeoDNS providers. Learn about popular GeoDNS providers such as Amazon Route 53, Cloudflare, and Akamai. Okay. Understand the specific features and capability of your chosen GeoDNS provider. Creating DNS zones. Hmm. All right, so I can say, tell me about DNS zones, geographic regions, DNS failover, load balancing. And we're going to stop there for now. And let it go. And again, we cannot trust any of this as ground truth. Hmm. All right, let's ask it another question. How might I achieve this in practice on, say, Squarespace? Not sponsored, by the way. I don't have any sponsors. All right. So it provides basic DNS management, but does not offer GeoDNS, DNS failover. We need an external DNS provider. Now, I will acknowledge this is where one of the holes in my knowledge uh, comes from. I am accustomed to working with DNS records, A records, MX, uh, most of the standard common ones. However, I have never used more advanced DNS features because there hasn't been a need for it in my in my current workplace. So this is going to be an interesting thing to research. Yeah, integrate with a CDN. Well, we're creating a CDN. So that's not really going to help. All right, what are some options for us? Okay, all right, Cloudflare gives us some fun options. Okay, all right. So we have $20 a month, and it gives us a ton of features. Amazon Route 53, pay as you go, as low as 50 cents per month per hosted zone, plus charges for queries and other features. Okay, DNS failure, failover, GeoDNS. Okay. Google Cloud DNS. All right, I'm assuming it's pretty similar. DNS made easy. $14.95 a year for 10 domains. So we get GeoDNS, DNS failover, load balancing, extensive API for DNS management. Okay. Namecheap. $488 per year per domain. We're just getting cheaper and cheaper. It doesn't offer advanced features like GeoDNS. Well, that's not really useful. This is why ChatGPT, you have to doubt everything it says. It knows that I want GeoDNS, but it still suggested Namecheap, which doesn't offer GeoDNS. Cloud DNS. Just because it's cheap and it seems to have most of what we need, I like DNS Made Easy for $14.95 a year. Has GeoDNS, DNS failover, load balancing, a good API. And it might seem like Amazon Route 53 or Google Cloud DNS might be even cheaper at 50 or 20 cents per month, but that's only a starting at price. They always get you on charges for, as it says up here, queries and other features. Oh, GeoDNS and advanced features are available on higher tier plans. Well, I'll have to do a more comprehensive look at all of these, but I'm not going to look at pricing too much more on this stream right here. I'm probably going to do that off camera. So I'm just going to write down a couple options for this. So GeoDNS. Oh, my apologies. Let's move you over. There you go. Now you can see me taking notes. So we have Namecheap, Amazon, what was it, Route 53, Google Cloud DNS, Cloudflare, which seems like it's going to be more on the expensive side because it has all sorts of plans, and it's probably more than we need. But we'll keep it in mind. Namecheap doesn't even offer GeoDNS. We're going to look at Cloud DNS. Hurricane Electric DNS. Okay, again, doesn't have GeoDNS features, so that's useless for us. And same with this one, so we're not going to include those in our list. Again, I'm going to look at all of these ones off camera. I'm not going to subject you to my looking at pricing all over the place. That said, the next thing we're going to research, let's see, we're going to look at, actually, that's the last one because I decided we were going to skip DDoS protection for now. I am going to go with most likely Redis and or Postgres for caching long term. Just because I love those and I know that they are quite performant. So I'm just going to go ahead and write state storage and caching. All right. That's going to do it for research. Let's go ahead and finalize our tech stack decision. That's the big thing I want to come away with from this stream. So again, the criteria that we're looking for are scalability, performance, and cost. So we have Golang and Rust here. Golang is pretty performant and it is highly developed for scalability and, or rather, concurrency. I believe either of these will be just fine for scalability because they can simply be scaled horizontally by spinning up new servers. Rust, however, is most likely going to be more performant as it is specifically designed for that. And it does have good concurrency support as well. I think that's what I'm going to go with in this project, which means I have some learning to do. For load balancing, I think I like Traffic because it integrates apparently quite well with Kubernetes and Docker, which I already know that we're going to use. In fact, I should probably mention that here in the tech stack. Containerization. Did I spell that right? I think so. So we're going to go with Traffic. Again, anyone disagrees with any of these decisions I'm making, I would love to hear about it. GeoDNS. I am still not quite decided on this, but apparently they're all going to give fairly similar service. It just depends on the price. And I'd say that means we're about done with our tech stack. You know, the front end, we can just use whatever we want. Most likely it's going to be React or something similar with, well, honestly, it's just going to be for management. Any clients most likely will only have a very minimal front end to deal with. So, with that being said, I know there's no one currently watching, but anyone watches this later, I would love it if you go ahead and like and subscribe and hit the notification bell so that you know when I'm streaming next. Next time we stream, I haven't decided just yet if I'm going to learn Rust on camera or off, but I'm going to start trying to program our, some of the more basic parts of our CDN next time. All right. Well, I will catch you then. Bye.